Y32.10. The symbols build upon basic geometric shapes, lines and modifiers to depict how fluid flows, pressure is controlled, and mechanical work is accomplished. 1. Core geometric shapes, component categories. Every component symbol starts with a fundamental geometric envelope that defines its broad function. Circle, energy conversion or rotary devices, pumps, fluid motors. Square, Blasch envelope, valves and control elements, directional control, pressure valves. Multiple adjacent squares show different valve switching positions. Diamond, fluid conditioning components, filters, strainers, oil coolers, heaters, desiccants, dryers. Rectangle, actuators providing linear motion, hydraulic cylinders or reservoirs/tanks. Triangle, flow direction indicators. Solid black triangle right, represents hydraulic liquid flow. Open triangle right, represents pneumatic airflow. 2. Line types, fluid and signal connections. Line styles define the function of piping, tubing and control connections. Solid line, primary working flow line, delivers high pressure power to actuators. Dashed line, pilot line, delivers fluid signals to actuate or pilot other valves. Dotted line, drain or case bleed line, returns low pressure leakage back to tank. Dash dotted line, -deed, enclosure by assembly outline, groups several individual components inside one block or manifold. Solid dot at intersection, bullet, connection point where lines join. Crossing lines without dot, Math BF+, lines crossing each other without connecting. 3. Key component symbols reference, pumps and motors, circles with triangles. Fixed displacement pump, circle with a solid triangle pointing outward toward the port. Variable displacement pump, same as fixed pump with a diagonal arrow superimposed across the circle indicating variable adjustment. Hydraulic motor, circle with solid triangles pointing inward, receiving fluid to turn. Actuators, Ballet cylinders, rectangles. Single acting cylinder, one port, extended by fluid, retracted by external force or internal spring. Double acting cylinder, two ports, fluid pressure actively drives the piston both forward and backward. Cylinder with cushion, a small square notch inside the end position to damp end of stroke impact. Valves, squares. Directional control valve, DCV, shown as connected boxes. Each box represents a distinct spool position. Internal arrows show flow directions in each active position. Number of ports, P, T, A, B, and number of positions define the callout, e.g., 4/3 way valve equals 4 ports, 3 positions. Pressure relief valve, single square with an arrow offset from ports, held closed by a spring. Opened by pilot pressure when line pressure exceeds spring force. Check valve, a ball sitting in a V seat. Allows flow in one direction, blocks return flow. Flow control valve, parallel curved lines representing a throttle or orifice, often with a diagonal arrow for manual adjustability. Fluid conditioning and drying, diamonds. Filter Blasch strainer diamond with a vertical dashed line down the center. Water separator Balsch trap, diamond with a small triangle at the bottom point to collect condensate. Desiccator fluid dryer, diamond containing a dotted pattern or drying matrix symbol used to extract moisture from system fluids, gas lines. Heat exchanger cooler, diamond with inward pointing arrows extracting heat. Heater, diamond with outward pointing arrows adding heat. 4. Actuation methods, how components shift. Small control symbols attached to the side of valve envelopes indicate how they operate. Actuator type. Symbol description. Manual lever. Line ending in a small handle/lever. Push button. Convex mushroom head or flat button. Solenoid. Diagonal rectangle with a /DC or zigzag, AC. Closing parenthesis. Pilot pressure. Small triangular envelope on the side, fluid or air pilot. Spring return. Zigzag spring coil, pushing the spool envelope back to neutral. How to read a circuit diagram step by step. 1. Locate the power unit. Start at the reservoir tank symbol, open or close rectangle at the bottom, and follow the continuous line to the main pump. 2. Trace the primary working line. Follow the solid lines out of the pump through conditioning units, filters, coolers to the primary control valves. 3. Analyze valve states. Read directional control valves in their unactuated de-energized state, the position where springs push the spool. 4. Follow pilot lines. Trace dashed lines to understand what pressure threshold triggers automated pilot-operated valves. 5. Identify the work. Follow lines through the valve envelopes to the cylinder or motor ports to determine direction of movement.